Let's be honest, there's nothing that ruins your day quite like that little check engine light popping up on the dash, right? It's just this universal symbol for, well, this is going to be a headache. But what if I told you it doesn't have to be?
So there you are, driving your Ford, everything's fine, and then, boom, there it is. But you've done the smart thing. You grabbed your code reader, and now you're trying to figure out what on earth your car is trying to tell you.
And that's probably why you're here. You're staring at code B1082, and it's got that little /13 tacked onto the end. Well, don't worry, you are in exactly the right place. We're going to break down what this means, and more importantly, how you can fix it. Okay, let's dive into this. This code, it's not just a random jumble of letters and numbers, it's actually a very specific message from your car. And it's all about your HVAC system, your heating and your air conditioning. The big takeaway here is that this code points directly to one thing, the right temperature damper motor. You can think of this motor as kind of like the little gatekeeper that's blending the hot and cold air for your passenger side. And that 13 at the end, that tells us the exact type of problem. It's an open circuit. Now, that term, open circuit, I know it sounds super technical, but the idea behind it is actually really, really simple. So let's break down what it actually means for your car. The technical version is this. Your car's main computer, the module, is trying to send power down to that damper motor, but it's getting total radio silence back. It's not sensing any voltage on the circuit. This could be because of something called a lack of bias voltage, or maybe just a super low flow of electricity. But here's an even simpler way to think about it. Imagine you flip a light switch in your house, but somewhere in the wall, the wire to the light bulb is just cut. The electricity has no path to get there, right? The circuit is open, and because of that, the light bulb is never going to turn on. That is exactly what's happening with your damper motor. So if we know we've got a cut wire somewhere in the system, the next question is pretty obvious. Where's the break? Now we get to play detective. We're going to move into the diagnostic phase and find the real culprit. And here's the really good news. For this specific code, the problem almost always comes down to just one of four main things. And that makes our investigation a whole lot easier. And this right here, this is basically our roadmap to the fix. What's so great is how it lays out every single possibility and tells you exactly what to do. So whether there's just no voltage on the circuit, which means you've got to check the wiring, or maybe a faulty part is causing that lack of bias voltage, or it could even be something as simple as a loose connection causing low current. The answer is right here. All right, we've got our roadmap. Now it's time to put on the mechanic hat and turn all this information into action. We're going to walk through this step by step, starting with the really easy checks first. First things first, you always want to start with the simplest and, let's be real, the cheapest potential fixes. Get a good flashlight and take a close look at the wiring that goes to that right temperature damper motor. Do you see any wires that are obviously broken or frayed? Is the wiring harness connector plugged in all the way? Sometimes, and this is the best case scenario, the fix is literally just plugging something back in nice and snug. Okay, so what if the wiring and the connections all look good? Well, our next step is to start looking at the parts themselves. That lack of bias voltage we talked about, that's often caused by a faulty component, like the damper motor itself or maybe an actuator. The key here, and this will save you some cash, is to confirm the part has actually failed before you go out and buy a new one. Once you're sure it's dead, then you can go ahead and swap in the new parts. And just like that, you've gone from having this confusing code on your dash to having a super clear understanding of not only the problem, but also the solution. So let's just do a quick recap of the most important things to remember. So remember the game plan, okay? Always start by just looking at the wiring and the connectors. Your problem might be a totally free fix. A loose plug is a super common cause of low current. And please, before you buy anything, try to make sure the old part is actually broken. The most powerful tool you have now is the knowledge to trace this problem right to its source. You see? You're not just staring at a light anymore. You get what it means, you know the most likely causes, and you've got a clear plan to get it fixed. So I guess there's really only one question left. Are you ready to get under the hood and get this done?